Today, last time we did circles, I believe. Today we'll be doing triangles. And before we start, I'm going to have to introduce some concepts to you. And the concept is about something called congruence and similarity. So what is that? All right, so we're doing triangles, okay? Also got two different triangles. So here's this one, and here's this one. So they're the both sides, okay? So let's say this is angle X, this is ABC, ABC. So you see these two triangles, they are the exact same replicas of one another, right? Even this triangle, instead of drawing how it looks, I can also draw it the other way around, like this, where the angle is still X, and this is BC, this is A, this is B. Now this triangle is the exact same thing as this triangle. This triangle is also the exact same thing as this triangle. The only difference is this one in green has been flipped, right? But ultimately all three triangles, they have the same shape and the same size, because A there is still A here. A could be 5, 10, 15, it doesn't really matter. So if they have the same size and the same shape, they are called congruent triangles, okay? They are the exact same triangles, maybe in a different orientation, but the size is the same, congruent. On the other hand, let's say we have this triangle, 20 degrees, and let's say this is 5, this is 10, yeah? Then we have a bigger triangle, same thing. The angle is going to be the same, except it's going to be enlarged, okay? Let's say this is 20, and let's say this is 40. Now, if you look here, these two triangles, if this is 90, this is 20, then what's the third side of the triangle? The third angle. The angles in a triangle always adds up to what?
180.
Right, so if one angle is 20, one angle is 90, what should the other one be? So it's going to be 90 minus 20 minus 20 minus 90, right? 180 minus these things.
70.
70. So they both are triangles. They have all three exact angles, yeah? But are they of the same size? No, they're not. You see, this is 5. This is 20, yeah? So this kind of becomes like a ratio question. How many times bigger is 20 than 5?
15.
No, times. Ratio means it's always times or divide. We're not trying to add something. We're trying to multiply 5 by something to get a 20. No? 2 is to 8 is the same thing as 4 is to what?
20.
2 is to 8 is the same thing as 4 is to 20? Nope. What did
16.
Yeah, 16. What did we do with the 2?
You multiplied it by 4.
We multiplied this by 2. We should also multiply this by 2, yeah? In this case. And you see this 2, the times 2? What did we call this? There's a name for this. It starts with S. It's the scale factor, okay? It's called the scale factor. Same thing here. This is basically kind of like a follow-up on the ratios. This is 5, this is 20. What's the scale factor?
4.
4, exactly. So we multiply this by 4. We also multiply this by 4. You see that? So these two triangles, they have the same angles, but they don't have the same size. So this means that these two triangles are similar, okay? Similar, what does that mean? It means same angles, okay, but different size. Cool? 2 is to 7 is the same thing as 8 is to what?
28
Yeah, what did you do?
and multiplied by 3.5.
I don't think it was 3.5. You gotta look at it this way, right? You gotta look at it this way. Not here to
Oh,
here.
okay.
Not here to here. That won't help you. So we multiply this by a 4, we multiply this by a 4. Okay, that's the scale factor. So the scale factor here is a 4.
Mm-hmm.
Therefore, in summary, congruent triangles are they have the same size and the same angles. Okay,
Mm-hmm.
whereas similar triangles, they have the same angles, but they don't necessarily have the same size.
Mm-hmm.
Cool.
Yep.
That's pretty much it. I mean, well, that's the idea, but then let's do some questions. Here, ignore A, look at B. It says is triangle, again, this symbol is triangle. Triangle DEF, which is this one, is it similar to triangle ABC?
Yes.
How can you tell?
Because the angles are the same.
So the angles have to be the same, but the scale factor also has to be the same, okay?
Mm-hmm.
Scale factor has to be the same. What did we do to 1.2 to get 2.4?
Um,
What's the scale factor?
2.
2, right? So scale factor is 2. Now, if you multiply 1.5 by 2, do you get 3.7?
No.
No, you don't. So these two triangles are not similar, okay?
Mm-hmm.
Because if they've been increasing by the same amount or by a similar amount, the scale factor should have been the same. In this case, this times 2 is not that, so these two triangles are not similar. Alrighty?
Mm-hmm.
Now let's look at these. What do they want here? Calculate the scale factor that relates the side lengths of large logo to the side lengths of the smaller one. All right, so we have the large versus smaller one. All right, there we go. So we have this as one big diagram, okay? And we have this as the smaller diagram. This one is this one is this. Question 1, are they similar?
Um, yes.
Yeah, so what's the scale factor?
4.
Right, so if this was 6, what would this be?
Um,
If the base of the bigger triangle is 6, what's the base of the smaller triangle?
1.5.
Correct. And there we go, easy as that. Sometimes they will ask you to prove whether two triangles are similar, okay? What if they don't give you any side lengths? So you have three triangles here, A, B, and C. Which two triangles are similar?
A.
I'm trying to find similar triangles. Any ideas?
A and C.
A and C, right? No, that's a trick question because for similar triangles, the angles have to be exactly the same. Only the sides are scaled up and down, right? The side lengths are scaled up and down, not the angle. The angle has to be exactly the same.
Oh, okay.
Okay, so this was a trick question. But this one is not, though. This one is a straight as you see it. Show that the two triangles in this diagram are similar. All right. Where are the two triangles in this diagram? What's the name of the two triangles? I'll give you one of them. One of them is CDE, you see? Triangle CDE, the one on the top.
Mm-hmm.
What's the other triangle? Do you see any other triangles in this? Look at the bigger
Not
picture.
really.
Say that again.
Um,
There's a bigger one, right? BDA, look at that, or BAD, it's the same thing.
oh, okay.
So we have triangle BDA, which is the bigger guy, right? Tell me the side lengths of BDA. What's the side length of B to D?
14 centimeters.
Correct. What about D to A?
Um, 11.6.
D to A, you got 11.6. How'd you get that?
Oh wait, it's wrong.
It'll be in terms of Y. We don't know what Y is.
Mm-hmm.
So what's the length from D to A in terms of Y? It'll be 3.6 plus Y, okay? Just like how you did 8 plus 6 to get 14. You would do 3.6 plus Y to get D to A, and then finally on the bottom we have X, the distance from B to A, the side length.
Mm-hmm.
And the question is asking us to show that these two triangles are similar. How can we do that? In order to prove that two triangles are similar, you have to show that two of the angles are the same.
Mm-hmm.
Which two angles are the same for these guys? You see the angle B down here?
Mm-hmm.
Which of these angles is the same thing as angle B?
C.
Yeah, exactly, C. So we proved one of the angles is the same. We can say that angle ABC, okay? ABC means this one, is the same thing as angle ECD. See, ECD, not ECB, because that would give us this bottom angle, ECE.
Mm-hmm.
Which other angle is the same? Look at the other pointy end of the triangles. Well, you don't even have to do that. They both have angle, this angle, they both have it. You see this angle D on the top?
Mm-hmm.
This angle D on the top, they both have it, right?
Uh-huh.
So there you go. That's another angle that's same. From the smaller one, you can say it's CDE, and that's the same thing as angle what from the bigger one. We're trying to write this in terms of angles.
BDA.
Yes, BDA. And since two angles are the same, the third is automatically the same. This means that these two triangles are similar, okay?
Mm-hmm.
Now, if they're similar, what do we look for? How are they related? They're related by the scale factor. Yes?
Mm-hmm.
So you see 6, we had 6 here. This became 14. So what's the scale factor?
Um, 2.3.
Yes. So if this is 6 down here, what is this x?
14.
Correct. X is 14. If this is 3.6, what is the side length of this side?
8.4.
Right, 8.4. So this entire thing, right? This entire thing is 8.4. But they're asking us to find y, so we're just going to set it up equals to 8.4.
Mm-hmm.
So how do we solve for y from this equation?
You subtract
Subtract what?
3.6.
Exactly. And what does that give you? 4.8, yeah?
Mm-hmm.
And there you go. That's the final answer for this question. Cool?
Hi. Sorry, my thing disconnected.
All right, let's look at this question. What is it even asking? Look at, read this statement out for me. What is this asking? What does this mean? All these symbols.
Is it the same?
Yes, it's asking us whether triangle ABC is similar to triangle DEF.
Mm-hmm.
So how do we do that?
Um,
Two angles must be the same, okay?
mm-hmm.
Two angles must be the same. If this is 36, this is 67, what's the angle down here?
Um, 87?
Right. Is that the same thing as 77?
No.
How did you get 87 down there?
Wait, I'll do it again. Oh, it's 77.
It's 77. So are two angles the same?
Mm-hmm.
They are. So they are similar indeed, okay? You can also check for the scale factor. Look at this. 3.3 to 1.1, it's times 3. 1.7 times 3. 1.8 times 3, yeah? The scale factor
Mm-hmm.
also checks out. So it must be similar. Which triangle is congruent to triangle ABC? Now congruent means it has to be exactly the same. Okay? The orientation
Mm-hmm.
might be different. So this is our starting triangle. The question is asking us which one is the exact same thing as this one.
The one on the other end.
Right, this one, right? So
Mhm.
these two are congruent. Part B is asking us which one's the same, which one is similar but not congruent. So it means it might be different in size, but it still has 3 equal angles.
Um,
Well, it
are
has
the
to be
3
this one.
first ones?
It has to be this one, no? See, they have all 3 of the same, the tick mark, the right angle, and the star. You see?
Oh, okay.
So that one has the exact same angles. Now the question is, what's going on here? Let's look at this one. Are these two similar? So in this case, they have not really given us the angle to work with, but we can still look at the scale factor, right?
Mhm.
Does a scale factor add up?
It does.
It does, right? Because the hypotenuse times 4, the base times 4, the side length times 4. So that is indeed similar, okay?
Mhm.
So this one is similar, this one is similar, this one is congruent. Let's look at the one on the top. What about that one? By the one on top, I mean this. Is this and this, are these two triangles similar?
Um,
What do you think?
yes.
How do you know?
Um,
Because the scale factor is the same, right? What would be the
mhm.
hypotenuse of this angle on the top? What would be the hypotenuse?
It would be 5.
It'll be 5, right? So this 5 times 2, 10. And the base is this one. And the longer side is this one. So all 3 are times 2 times 2 times 2, right?
Mhm.
So there we go. Those two triangles are similar. What about this one? Are these two triangles similar?
Um, I think so.
Well, just compare the scale factors. What's the scale factor in this case?
It's 2.
So does it add up, all 3 sides? Does that hold?
Mhm.
Yeah, it does. So it must be similar, okay? And if it's similar, that means this angle is the same thing as this, and this. If the scale factor holds up, it is going to be a similar triangle. Let's look at another one here. Suppose that triangle PQR, all right, let's just make this. We have PQR And then we have LMN. LMN, and they're similar, so they don't necessarily have to be the same size. And we know angle P is 90. So actually, then I'm gonna have to relabel this, don't I? P is 90, so P should be in the middle. P, this is 90, QR. That means it's L, M, and N. Okay, there you go. That's our setup. What angle in triangle LMN equals 90? How do you know?
L.
Yes, that's right, because we just drew it and it has to hold, right? If it's similar, then if P is 90, L must be 90. If MN is 13, so this is 13, and LN is 12, and LM is 5, PQ is 15. What would be QR and PR is the question. We're trying to find this side length and this side length.
39 and 36.
Yeah, absolutely right. Because the scale factor is 3 and easy as that. This one, it says determine the length of dB. So we're trying to find the distance from here to here. Cool. Any ideas on how to start this? Well, the first step is you have to notice that there's two different triangles in there. Do you see them? What are the two different triangles? What are the names of the two triangles in there?
CAB and EAD.
Yeah, CAB and EAD. So this is a smaller one and this is the bigger one, okay? Next step is you have to show that they're similar. So in order to show that, you need to come up with two angles that they both have, which are equal. So which two angles are equal from the smaller one to the bigger one?
D and B.
Right, D and B. So in the smaller one, we have A, B, C, and this is the same thing as in the bigger one, we have A, D, E, yeah? What about the other angle? That's one of them. So we've dealt with these. We need one more angle.
A.
Yeah, exactly. They both have A. How do you say A from the special triangles perspective?
What do you mean?
So try to write angle A, right? From the smaller triangles perspective, it's going to be BAC. BAC. Yeah? BAC. What about from the bigger triangles perspective? How do you write angle A?
DAE.
Yeah, DAE. You see two angles are the same from the smaller one to the bigger one. Therefore, triangle CAB, the smaller triangle, is similar, and the similar symbol is this one. Similar to EAD, okay? It's wiggly sign. Okay, now we can start doing some maths. Any ideas on how to do this question now? We're trying to find D to B.
Mm-hmm.
You can't find that straight up. Step one, you're gonna need to find the scale factor. Okay. Now notice they have not given us any two sides, so we can't find the scale factor straight out. But what we can do, if you look at CBA, right, CAB, if you look at the smaller triangle, we have one side, we have two sides, we can find the third side. How do you find the third side of triangle CAB? This side. How do we find the line segment CB?
You square the other two numbers and then subtract them.
Okay, why don't you do it? Tell me what you get. Length of CB is the question.
160. Wait.
Nope, not even close.
12.6.
Nope. So this is A, this is B, this is C, right? Pythagoras theorem says a squared plus b squared equals c squared. We're trying to find a here. So a squared is gonna be c squared minus b squared, yeah?
Mm-hmm.
A squared is this, and what's c squared? C squared is square root of 13 whole squared minus 3 whole squared, right?
Mm-hmm.
And again, this is a squared, and a squared is gonna be square root of 13 whole squared is straight up a 13. 3 squared is a 9. This gives us a squared is a 4, and then square both sides, a is 2.
Oh, okay.
There's no way side A is going to be bigger than side C. Square of 13 is like 3 point something. CB cannot be higher than or greater than the hypotenuse. So we know the segment CB is 2 centimeters. Now this will help us find the scale factor. Which two sides do we compare?
CB and ED.
Right, so what's the scale factor? What do we multiply by 2 to get 2.5?
1.25.
Right, so scale factor, okay? Scale factor is 1.25. So if BA in the smaller triangle is 3 centimeters, what's going to be the base of the bigger triangle, AD, using the scale factor?
3.75.
Right, 3.75. Now finally, therefore, what's the segment, what's the distance from D to B? We know D to A is 3.75. We know B to A is 3. So what's the distance from D to B?
0.75.
Correct, and there we go. That's the final answer. Okay. A bunch of things, multiple steps. Looks easy, but if you just follow the pattern, I guess it's not that bad. A new bridge is going to be built across a river, but the width of the river cannot be measured directly. Surveyors set up posts A, B, C, D, and E. Then they took measurements. The question is, find the width of the river, side AB. Any ideas on how we can do this?
You find the scale factor.
Which two sides? No, step one, you're gonna have to prove that both of these triangles are similar first in order to use the scale factor. How do you prove they're similar? By showing that two angles are the same. So which two angles does the bigger one and the smaller one have in common?
C and for both of them it's C and
Right.
then A
This
and
one.
D.
Right, so this is called vertically opposite angles. They're the same, and they both have a right angle. They're the same. So now we've shown that they are similar triangles. Now we use the scale factor. What's the
Mm-hmm.
scale factor here?
5.5.
Right, so what's going to be the width of the river?
Um, 71.5.
Right, let's see if you are correct. Oh, I think you are. Yeah, 71.5, same thing as 72, okay?
Mm-hmm.
Let's try doing another one. I don't know if this is a girl's name, but we're gonna roll with it. So this person's standing behind a lighthouse. And the question is, how tall is the lighthouse? The question is, which two angles do they both have in common? Because in order to use the scale factor, we have to show that the two triangles are similar.
They both have a right angle.
They both have a right angle, that's right. What else?
Like the front part is the same.
The pointy end is the same, yeah?
Mm-hmm.
This one. Because you see
Uh-huh.
the sunlight is going this way. So there's like two triangles in here. Yeah, they're the same. So now we've, wow. So we have now identified the two similar triangles. Next step would be to find the scale factor.
15.6.
Okay, that means what's the height of the tower of the lighthouse?
25.
Okay, let's see if you were correct. Oh, and you are, and there we go, easy as that. Okay.
Mm-hmm.
Let's go off on a little bit of a tangent. Because why not? Ever noticed how they could possibly measure the height of mountains? No one has a 8 kilometer, like, like a tape that they can just be like, oh, it's 8 kilometers like that.
Mm-hmm.
They use this technique, right? What they do is
Mm-hmm.
they stand at a certain angle. This we can measure. Okay, we can measure this angle, okay?
Mm-hmm.
And we can measure the distance, how far away they're standing from a mountain base, right?
Mm-hmm.
From the same point, they put a pole or something here, okay? To that angle, they establish like a tower or a small rod, whatever. Then they measure this distance. And you see they use the scale factor from here to here, right? Must be the same thing as here to here.
Mm-hmm.
That makes sense?
Uh-huh.
It's a small, simple concept, but very wide uses. There's more to this, obviously, but this is the bare bones idea. What they actually do is they do it. They use a technique called triangulation, where they would measure the height from 3 different parts or 3 different corners of a triangle, just to make sure it's as precise as it can be.
Mhm.
This is called surveying. This is a job that people can get into. It's like maps, surveying, like navigation, all comes under this. This is something you can study in university if you are interested in it. Anyways, let's do one more question before we move on from this section. A 3.6 meter ladder, all right, is leaning against a wall. So let's say this is the wall and this is our ladder, okay? It's
Mhm.
leaning across a wall. If it's leaning across a wall, what kind of an angle does it make at its bottom? At the bottom of the wall?
A right angle.
Right, a right angle. And we know the ladder is 3.6 meters and its base is 2.2 meters from the wall, yeah? Like that.
Mhm.
Draw a scale diagram to represent the situation. There we go. Suppose that a 2.4 meter ladder is placed against the wall parallel to the longer ladder. So now what's happened is that we're putting parallel means this ladder and this ladder should be the same, yeah?
Mhm.
And this ladder has a length of 2.4 meters. And it says find, actually, first question is explain why the triangles formed are parallel or similar, sorry.
They both have right angles and like the same front angle.
Yeah, exactly. They have this the same and they both have right angles. So that means they are equal or not equal. Sorry, they're similar. Equal would mean they're congruent, but they're not congruent because they have different side lengths. So you can remember from here to here is 2 meters, okay?
Mhm.
How far up the ladder will each, how far up the wall will each ladder reach? So now we're trying to find this distance and this distance from here to there and from there to there. Any ideas on how to do this question?
We use the Pythagorean theorem.
Right, right. So that would, let's first find the height of the taller ladder.
Mhm.
Tell me what you get. Use a calculator. And there's absolutely no way that height is going to be greater than 3.6. It has to be smaller than 3.6. Plug it in a calculator and tell me the height from here to here, the height of the taller ladder.
2.9.
2.9?
Mhm.
Alrighty, that makes sense. Now we're trying to find this height, right?
Mhm.
How do we do this?
You do the same thing.
Try it.
But what about the bottom? Is it just half of 2?
No, you're gonna have to use the scale factor, right? So let's first find the bottom, maybe that'll be easier. So what's the scale factor? Compare the two sides that we do know, 2.4 and 3.6.
1.5.
Yeah, 1.5. So what would be the length from here to here? If the whole thing is 2, from there to there.
Um.
It'll just be 2 divided by 1.5, right?
So 0.75.
Yeah, 0.75. Now use this side and the Pythagoras theorem to find the height of the smaller ladder.
Is it 5.2?
No, again, it cannot be
No.
bigger. It cannot be bigger than the hypotenuse, right? Hypotenuse is always the longest side. So if this is 2.4, this is 0.75. We can just use Pythagoras theorem, a squared, b squared, c squared. B is gonna be the square root of 2.4 squared minus 0.75 squared. Right, because b squared is c squared minus a squared, and to solve for b, you just square root both sides. So it'll be square root of 2.4 squared minus 0.75 squared. The answer is 2.28.
Okay.
Let's try doing this one. This one, it says triangle ABC is the same thing as triangle RST. So let's say this is ABC. Again, it doesn't really matter where you put the angles, ABC. And let's say this is RST. Look at A. It says angle ABC is the same thing as which angle on the other triangle?
RST.
Correcto. Angle RST. Angle BCA from the big one is the same thing as what?
STR.
Yes, STR angle. Look at C. AB over RS is the same thing as what over what?
Do you just switch them?
Mm-hmm.
RS over AB.
By that I meant you need to pick two other sides, any of the two other sides. You can do this over this or that over that.
Oh, BC over ST.
Right, BC over ST. What does this give? This gives you something. Both of these, they gave you the same thing. What is that thing called?
Is it the scale factor?
Correct, it's the scale factor. And there's a notation for that. We're gonna call it K. K is the scale factor, okay? This one, it says triangle STR is similar to.
BCA.
Correct. STR, BCA, yeah. BCA. ST over BC is the same thing as.
RT over AC.
Right, RT over AC. And then finally, angle SRT is the same thing as.
BAC.
Yes, okay. So there you go. That's all about similar triangles. Let's look at this one. Write a proportion. Proportion just means something over something. Step one, are these two triangles the same?
No.
No, they're not. Yes, it is. They're trying to trick you. Okay, see, it's not in the right orientation, but what we can do is I can take this guy, right? And what we can do is we can flip it. What about now? Right,
It
overflip
is the
it.
same.
Looks like it is, right? Oh, wait, let me just try to make this straight. Yeah, like that. It is the same, right?
Mm-hmm.
Because angle X is the same thing as angle X, and angle O is the same thing as angle O. So they want us to write a proportion. So here, let me give you one of them. E over C is the same thing as what?
Um,
E over C is the same thing as,
A over F.
no. E, the bigger one came first, right? E over C, big over small, F over A, not A over F.
Oh, okay.
The bigger one comes first, so you have to put the bigger one first. What if I said B over D? B over D is the same thing as what?
Um, C over E.
Yes, C over E works, right? Because smaller one, and A over F also works in this case. Cool,
Mm-hmm.
easy as that. That one's a pretty basic question. Let's try doing this one. A right triangle has side lengths 6, 8, and 10. A right triangle means there should be a right angle somewhere, right? Which side is 6, which side is 8, and which side is 10? Any ideas?
Do you draw another triangle?
Oh, no. It's going to be in this triangle first. We're trying to label 6, 8, and 10 on this triangle. Here,
Um,
I'll do this one, okay? 6, 8, and 10. We know this is a right angle triangle. The hypotenuse is always going to be the longest side, so this one has to be 10.
mm-hmm.
6 and 8, it doesn't matter. You can put that as 8, 6, or you can do 8, 6 here. It doesn't matter.
Okay.
So what they're saying is this is the first triangle. The longest side of a larger similar triangle. So there's a longer triangle here, right?
Mm-hmm.
And it says the longest side is 15. So which side is 15 on the second triangle?
The hypotenuse.
Right, the hypotenuse. So what's the scale factor?
Um,
What do you multiply by 10 to get a 15?
1.5.
Yes, 1.5. So what's this side gonna be? What this side gonna be?
The bottom side is going to be 12,
Yes,
and the other one is 9.
9, exactly. And the question's asking us to determine the perimeter and the area of the larger triangle. What's the formula for the perimeter?
You just add all the sides.
Right, so it's gonna be 9 plus 15 plus 12, right?
Mm-hmm.
And that'll be 24 plus 12, that'll be 36. What's the formula for the area of a triangle?
Base times height over 2.
Right, so area is gonna be base is 12, height is 9 divided by 2. That is going to be 54. And what's the unit of area?
Centimeters squared.
Yes, exactly, centimeters squared. Cool.
Mm-hmm.
And easy as that. Let's see what we'll be doing tomorrow. So pretty much the same thing it looks like. Yeah, these two triangles are the same, right? Because they both have right angles, they both have the pointy end on the front. Um, We'll be doing something new tomorrow though. Which calculator do you have? Hey, in your calculator, do you see a sign button? It's called SIN. You see like this, SIN, this. Do you have these?
Um, yes.
Yes, all right. You've never used them before in your life, have you?
Nope.
Tomorrow we'll be using those, okay?
Mm-hmm.
There you go. There's something to keep you up at night. Maybe not, but yeah. All right, let's call it a day there for today.
All right. Thank you.
All right, take care. Bye-bye.